Welcome. This is part 2 of the midterm review. So this is for macro. In part 1, we covered things like market equilibrium. We talked about supply and demand. We talked about a shift. We talked about price ceilings and price floors. That's something we also talked about in the problem set review, and we also talked about elasticity. So if you're having any issues with that, I would definitely check out part 1, or I would check out the problem set review. The problem set review goes in depth. It walks through all the steps, and it also walks it through just by hand. In this part, we're going to cover things more like nominal GDP, and we're getting more into our macro-centric ideas. So on the review, which is on Moodle, you can get the blank review, or the answer key is also up there as well if you want to follow along with it. The question number 5, Q5, covers nominal GDP. So in this economy, we have GDP. Remember, GDP is broken up by consumption, investment, government spending, and then we have our net exports, which is usually, if we remember correctly, our imports minus our exports. In this case, our economy here has a C, or consumption level, of 900. It has investment level of 400. It has a government spending level of 500, and it has a net exports of negative 60. So this is indicating to us one big thing. This is telling us that this particular economy is importing a lot more than it's exporting, which means to me that they're spending more than they're making. So our formula again for GDP is this one up here. All we gotta do is plug these values in. So let's do that. If our GDP in this country, our consumption is 900, our income is, our investment, so we got 900 for consumption, for investment is 400, and then we got 500, and then we got minus 60, right? All we gotta do is add these all together. This is gonna give us a GDP of 1,740. And that's it, right? That's our nominal. That's our nominal in the moment. That's our nominal, right? We're not doing anything to account for inflation from the prior periods. We're not looking into the future. And then the second question here is asking us about our per capita. Remember, per capita is looking at the population, and it's looking at like per citizen. So what is GDP per citizen? So if we look at B, this is the answer to A. If we look at it, this tells us we have a population of 82 million. All right, so we have a population of 82 million, and we have a nominal GDP, right, of, this is in the billions. All we gotta do is we can divide. We can do it 2 different ways. You can just divide, in this case, right, when we do GDP per capita, remember per capita is like per citizen. All that is our nominal. It's going to be our nominal over our population. Nominal over our population. In this case, what does that mean? Well, our nominal over our population, we can do it 2 different ways. We can either say just this 1740 over 82 and divide, or we can be fancy schmancy and we can add all our zeros in. 1740. And then we just have all our zeros in, right? like that. We can either have all our zeros or none of our zeros. Either way, we're gonna get the same answer or similar interpretation of it. In this case, you're gonna have to add the zeros back in, because remember, we're doing per capita, and when we divide this out, it's actually gonna give us a GDP per capita. So bring you back over here. Answer to B, GDP capita is gonna be equal to about $21,022. And there you go. And that's how we'd answer that first question. All right. Question 6 talks about real GDP. So this is where we're talking about inflation. So our nominal, think no, nothing. We are just thinking about no in the moment. Think real GDP as where we are talking about inflation, and we have to talk about it relative to other periods, right? So when we calculate our real GDP, we need two things. We need our nominal and we need our GDP deflator. Remember, our deflator is what we're using or utilizing to make reference to other periods. In this case, we're seeing that our GDP deflator is 109, so we're past that base year. And our base year is 100, right? So we're most likely going to see some inflation occur, right? Because we're going past that base year. We're going past our 100%. So the way we want to calculate our real GDP, our equation for real GDP looks like this. So real GDP is equal to we have our nominal over our deflator. Remember, sometimes we call this deflator in later chapters our price index. Price index and our deflators do pretty much the same exact thing. And then we multiply by 100 so we can get that percent interpretation. All we gotta do is plug the values in that we got. So we know that our nominal is 1645, our deflator is 109, and in that case, we divide that out, and we're gonna get 150,917. So our real GDP in this case, 150,917. So we compare these two, right? Our nominal in the moment looks like we made more money, right? But compared to a base year, which is probably about 9 years before that, it didn't grow as fast, right? That's because counting for inflation, we're counting for the devaluation of the dollar. And when the dollar slowly loses its value compared to years past, our increase in GDP is not going to look as crazy. So that was part A. We got to calculate that. In B now, what we do in B, part B of that question, is talk about last year. So last year, it says if last year's real GDP, so what do you call it? R. Last year's real GDP was 1560. We need to calculate the real growth rate as a percentage. So we need to calculate how it grew from the year prior to it. So I'm going to erase this. How do we calculate a growth rate? Well, growth rates are just percent changes, just like we did with elasticity, and they kind of do the exact same thing. All you do with a growth rate, or if we're looking for a change from one period to the next period, This little t plus 1 is representing like the next year. So if I did t plus 2, it would be 2 years. So if we're looking at a growth, anytime we look at growth, all it is looking at a comparison of the new to the old, a product of the new minus the old, and then we're looking at what the old looked like. We multiply that by 100 so that we can find a percent interpretation. So in this case, we plug our values in. We have our last year, we know our new real GDP, so we can subtract. I'm gonna round this up a little bit just to make this a little bit easier. So I'm gonna round up to 1509, and then I'm gonna plug that in just to make it easier. You don't have to. All right, so we got 1509 is our new. Remember, this is our last year. This is our current year. Last year, current year. So old, new, minus all right, we got that. Let's solve it out. This is going to be negative 51. So we can already see from last year to our year now, we didn't grow. And then 1560, and then multiply that by 100, and that's going to give us a negative growth rate, right? Our growth rate is going to look like this. So that tells me it fell. And that's our answer to B. It fell. Question 7 talks about the unemployment rates, right? So in an unemployment rate, we have our general population. So this is everybody, right? Everybody in our population in our economy. We have our labor force. So these are people who are either unemployed or employed. So our labor force are all of these people who are actively in our labor force, people who are not retired, not children, people who can participate in the labor force and want to. And then unemployed people, remember the important thing about being unemployed is the definition itself. You have to be actively seeking work out, and it depends on what kind of work you're doing. So if you are unemployed, you're actively seeking, but you do not have a job at the moment. So in this case, it's asking us first, we need to calculate the unemployment rate. So we have a population of 245 million, we have a labor force of 145, and we have an unemployment population of 7.5. So in this case, the first thing we want to do is our formula for the unemployment rate. Our unemployment rate formula looks like the unemployed over the labor force, and we multiply that by 100 so we can get the rate part, right? Rates are percentages. So in this case, our unemployment rate is going to look like this, right? We got 7.5 million people who are unemployed, and for a total of 145 people in our labor force, and we multiply that by 100. It's going to give us about 5.17%. Remember, it's okay to use a calculator for this. All right, that's our first part. That's our answer to A. That's our unemployment rate. The second part is our labor force participation. Right, our labor force participation rate, again, it's a rate, so we're going to have to multiply by 100 at some point so we can get that percent or that rate interpretation. Our labor force participation rate is our labor force over our total pop. our case, and we multiply this by 100. In this case, we have a labor force of 145, and we have a population of 245. We multiply that by 100, and that's going to give us a labor force participation rate of about 59.18%. And that's our answer to B. That's the answer to B. So when we do rates are pretty much broken down by a total and a portion, right? So each of these, if we look at unemployment, unemployed people are a portion of the labor force. So we have the total labor force and a portion of it. If we talk about the labor force and our total population, we have the total population and a portion of that population, which is the labor force. And then we always multiply by this 100, so we can get our percent interpretation of it. Give that a second. And that's question 7. Question 8 covers inflation rates. So remember, when we talk about this rate thing, this is when we're going to talk about percent changes, right? We go from one period to another. And in this case, we have the CPI, or our Consumer Price Index, of last year of 234. And then we have our CPI, our Consumer Price Index, this year of 265. So the way we want to calculate it is, the first thing we need to do is we need to calculate our inflation rate. So our inflation rate, just like most of the rates, when we talk about inflation, we calculate the rate by looking at the CPI, that's the new one, taking the old one away from it, or we look at the difference between these two things, and then we divide that by the old CPI. We're looking at that change, and then we multiply that by 100. So if we want to do that for this equation, it'll look something like this. So we're going to have our new, which is this year's our new 265. We're going to subtract our old 234. We already know that that's going to be a positive number, and we're going to divide it by our old 235 and multiply by 100. This is going to reduce down, so it's going to look something like this. We're going to have 31 over 234 times 100. And in this case, it reduces down a little bit to like this. It's going to be 13.25%. So we have an inflation rate of about 13.25%, which is pretty high. That's more than a 10% increase from the last time. The next part of this question asks about our nominal wage. So we want to put this aside, right? We calculated our inflation rate. We said our inflation rate was 13.25%. And now we need to look at our nominal wage. All right, so the second question asks us, or part B is asking us, it says if a worker's nominal wage increases, so if a nominal wage, so our wage is going up. It's going up from 55,000 a year to 62,000 a year. Not too shabby a pay raise. We need to say whether their real wage, so after inflation, did it decrease, increase, or stay the same? And show, kind of briefly explain why, right? This is where we take into account our inflation rate. So if our inflation rate is up, what we need to do is our same exact thing. We need to account for inflation. What we're going to do is we're going to take this new, subtract the old, We're dividing by the old, so we're seeing a percent change. We divide 7,000 by 55,000. That equals about 0.127, and we gotta multiply that by 100. So we get about a percent change of about 12.7%. So from our first year to our second year, right? So our old wage to our new wage, we calculated that percent change, or the change between them, right? The rate of change. We took our new and subtracted our old, found the difference. So the difference was we got paid $7,000 more. We then divided that by our old wage, and we found that our wage increased by 12.7%. So we now need to compare what we saw for our increase in wage, right? So our wages increased by 12.7%. What we need to compare is these two values. So is 13.25 greater than or less than 12.7? It's greater than, right? That means inflation was higher than our raise. So what actually happened was we had an increase in wages, but because inflation was so high, remember inflation is usually 2% or so, it's not 13%. Because of inflation being so high, that percent increase in our wage really didn't do anything. Our value of the dollar dropped so much that that increase in wage didn't account for it. And because of that, because inflation was higher than our raise, our purchasing power, or the amount we can buy for our dollar, power, fell. So inflation was higher than our raise, and our purchasing power fell, aka what happened was real wages, or what we account for with inflation, real wages decreased. If we had a situation that was opposite, so if our inflation rate was 12.7 and our wage increased by 13.25%, that would be the opposite situation, right? We would have an increase in wages that was higher than inflation, and our purchasing power would have increased. But because inflation was higher than our wage, our real wages decreased. One of our last questions covers opportunity costs. This is something we covered when we talked about budget constraints more in the beginning of the semester, and it's something that we come back to, especially when we consider firms and we consider gains and loss as an entire economy. So our opportunity costs. So we have an economy, it produces some kind of good, right? Maybe it has the advantage on this good. In this case, we have an economy at the point A, it produces 120 chairs, and it produces 75 tables, right? We could think about this as anything. You could say mangoes, pineapples, we could say oil and healthcare, we could say any big things, right? In this case, our economy produces chairs and tables. We're a very small island, we just do woodworking, I guess. At point B, so in this case, right, we want to draw this out. At point A, if we talk about this as chairs versus tables, at point A, we do 120 chairs, and we do 75 tables. This is point A. At point B, we do 105 chairs, and we do 55 tables. So at point B, 105 and 55. We need to figure out, for our first question, what is the opportunity cost of producing 15 more chairs? So, when we move from point A or point B to point A, our chairs are going to do what? So, if we go from point B to point A, chairs are going to increase, right? Chairs go up. That's about 120 chairs at point A and 105 chairs at point B. So chairs go up by about, this way. Chairs go up by 15. So we got 15 more chairs. From point B to point A, tables also go up. We produce more tables. In this case, we go 75 to 55. And we go up 20 tables. So from one point to another, we can produce 15 more chairs and 20 more tables. So, remember our opportunity cost, or what we give up to produce more versus to produce another. In this case, it means when we produce 15 more chairs, we're going to have to give up producing 20 tables. Remember, our opportunity cost is what we give up versus what you gain. So, in this case, if we're giving up making 15 chairs, we can make 20 tables. So the opportunity cost or opportunity cost of one table is 0.75 chairs. Meaning, to produce one table, we give up producing 0.75 more chairs. So remember, we're moving from here to here. And to go up and over, we have to give up something of something else. It's very similar to the way we do budget constraints, right? When we have a budget constraint, we have to give up one good in order to consume more of the other. When we talk about it as an economy, we have to do the exact same thing. To give up or produce more chairs, we would probably have to produce less tables. To produce more tables, we have to produce less chairs.